Hey guys, today we are going to start chapter 9 by talking about the theorem of Pythagoras. So today's lesson might not be brand new to you, as in I'm sure we've all seen the Pythagorean theorem before, but some things about the Pythagorean that you maybe didn't know before might come to light, as well as just a refresher on how it's used, because it's going to be used a lot as we proceed through chapter 9. Okay, the first thing that I think is the most important part about the Pythagorean theorem is knowing what A, B, and C represent. Okay, so remember, we only use Pythagorean theorem when we're dealing with right triangles. All right, and with these right triangles, we have legs. Okay, so the legs are A and B. Legs are adjacent to the 90-degree angle. Okay, and the hypotenuse is always going to be C, and C is always opposite the 90-degree triangle. Okay, so that's, or the 90-degree angle, excuse me. So that is the most commonly mistaken thing, is where the placement is. A lot of times people will see a number associated with C and a number associated with A, and they'll put that A plus C equals B, or A squared plus C squared equals B squared. But that's not how it works. Of course, we know that our two legs go on the same side together, and our C is opposite them. Okay, just some history on Pythagoras. Who is this guy? Okay, so Pythagoras was a mathematician back in 569 to 475 BC. Okay, so that's a long time ago. And he lived in Greece, and he started a mathematical society in what's now Italy, and none of his actual writings are actually in existence. All right, we don't know a whole lot about Pythagoras' life, but the math society that he started is the society that proves what we now know as the Pythagorean theorem. Okay, Pythagorean theorem was used far before that, over 1,000 years before that. So it's been around for quite a while, but Pythagoras and his math society is the first to have actually proved it, and so that's why it's called the Pythagorean theorem. All right, now that should be nothing new. Pythagorean theorem. Okay, so this is the verbiage that goes with it. In a right triangle, the sum of the squares of the lengths of the legs equals the square of the hypotenuse. Okay, I'm going to give you a second to write that down. All right, and as you're writing, of course, what this is saying is, first of all, it must be a right triangle. I cannot use the Pythagorean theorem in anything but a right triangle. The sum of the squares of the lengths of the legs, those are represented by A, so sum plus B, they're squared, okay, equals the square of the hypotenuse. And remember, we represent the hypotenuse with a C. Okay, so A squared plus B squared equals C squared. And the key here is it must be a right triangle in order for it to be applied. All right, everybody's favorite part, the proof. Okay, so let's prove it. All right, so I've got 4 triangles here. I've got a square in the middle, and I've got a big square here going around it. Okay, if you'll notice, every single one of these triangles in this picture right here has a C in the place of the hypotenuse and an A and a B for each particular leg. Okay, now in our previous chapters, we learned all about area. So why not apply what we know about area to see if it'll help us with our Pythagorean theorem? All right, so just going to kind of walk through this proof with you guys. So let's see. I need the area of the entire big square. I need the area of the entire big square. So to get the area of the entire big square, I'm just going to do base length times height. Now, the base is A plus B. Okay, and the height is A plus B. All right, now I have to FOIL that. So if I FOIL that out, I get A squared plus 2AB plus C squared. Or, excuse me, B squared. I'm sorry. Okay, so that gives me the area of the entire thing. Now, I want to figure out what the area of the square is without these 4 triangles. So I have to subtract the area of the 4 red triangles. In order to subtract the area of the 4 red triangles, let's get the area of just one triangle. So the area, so this is the area, I'm going to say, of the big square equals that. So the area of a triangle is 1/2 AB. Okay, so let's just take this for example. So that's 1/2 AB. Okay, if I want 4 of those triangles, I'm going to go 4 times 1/2 AB, and that's going to give me 2AB. Okay, so if I combine these two, the area of the whole square and the area of the 4 triangles, I have to subtract those two to get what's left. So a squared plus 2ab plus b squared minus 2ab. Area of the big square minus area of the triangles. So area of what's left in here is a squared plus b squared. Now, the Pythagorean theorem tells me that a squared plus b squared equals c squared, so I can use what I know about this square to prove it. Now, do I know it's a square? That's the key right there. Do I know this is a square? The only way that I can prove this is a square is to use what I know about angle 1, angle 2, and angle 3. Okay, I know that these 4 triangles are right triangles, but I do not know that that is a square. I do not have anything indicating that angle 2 is a 90-degree angle, so I have to prove it. What I do know is that angle 1 plus angle 2 plus angle 3 is 180 degrees, okay, right, because they form a straight line. Now, let's just look at angle 1 and angle 2, okay? If I'm just looking at angle 1 and angle 2, I'm going to duplicate that angle 1 over here because it has to be the same, right? If that's angle 3 and that's a 90, then that has to be angle 1. Now, what do I know about angle 1 plus angle 3? Angle 1 plus angle 3 has to equal 90 degrees. And the reason that's true is because it's a 90-degree triangle, and the triangle sum conjecture tells me that all 3 together are going to equal 180 degrees. 180 minus that 90 leaves me with 90 degrees between 3 and 1. So because of that, now I know that angle 2 is a 90-degree angle, making this a square. Now, because it is a square, to find the area of, I'm just going to call it little b, blue square, is simply c squared. So, bringing these two together, I found the area using the big area minus the 4 triangles, and I found the area using c squared, so I know a squared plus b squared equals c squared. Pretty cool. That's how we figured out. That's how we solve or prove the Pythagorean theorem. All right, so let's just do a couple practice problems, make sure we know what we're doing as far as using the Pythagorean theorem. All right, this first one. How high up on a wall will a 20-foot ladder touch if the foot of the ladder is placed 5 foot from the wall? Guys, the key to these, and they give us a picture here, but if they do not give you a picture, please draw a picture with your word problems. In 9.4, we're really going to dive into some tough word problems, okay, and a picture is going to make all the difference as far as word problems are concerned. Okay, but here's our problem, okay? I've got 20 foot, that's my ladder. The ladder is 5 feet from the base of the wall. It wants to know how high up the wall it goes, okay? So it's all about placement here. All right, so my Pythagorean theorem, a squared plus b squared equals c squared. All right, what's a, what's b, and what's c? Okay, right now I know without a doubt that 20 is my hypotenuse because it's across from the 90. So I'm going to do 20 squared equals b squared plus, let's do 5 squared. So 25 plus b squared equals 400. All right, now I'm going to subtract my 25. B squared equals 375. All right, and so doing the math here, the square root of 375 is 19.4 feet. Okay, so that's how high up the wall this particular ladder goes. All right, let's do the next problem. Find the area of the rectangular rug if the width is 12 feet and the diagonal measures 20 feet. Okay, so now we're dealing with something that's not even a triangle, it's a rectangle, but I want to use the diagonal. Now, because it's a rectangle, I know it's 90 degrees, and because it's 90 degrees, I know that I can use that particular diagonal in order to use the Pythagorean theorem. So if that's 12 feet, this is 12 feet as well. That's the definition of a rectangle. So again, it's all about placement. I've got L squared plus 12 squared equals 20 squared. All right, so now I've got 144 equals, L squared plus 144 equals 400. All right, so L squared equals 256. All right, and the square root of 256 is, what is that? So my next slide. It's 16, okay? So pretty easy stuff. All right, now that's just solving for L, so L is 16, but we still have not found the answer to the question. It's asking us for area. So if I'm going to find area of this, then now that I have the L is 16, area of a rectangle is base times height. So I do 12 times 16, and that's going to give me 192 square feet. Okay, so that's the Pythagorean theorem. Hope you enjoyed it. Talk to you guys later.